does it mean for a function to have a 0? By the end of this episode, you'll be seeing zeros everywhere, and you'll know how to use them in your functional programs. Hi, my name is Eric Normand, and I help people thrive with functional programming. So 0 is an important algebraic property that we use probably more than we realize. What it does is it lets you build operations that have a kind of short-circuited ending, right? So 0 comes from multiplication. The name 0 for this property comes from multiplication, where the 0 value actually is the number 0. So when you're multiplying and you have a 0 in there, say you have like this really long list of numbers to multiply, and let's say it's like 20,000 numbers, and you get 20 or 30 numbers in, and you say, hey, there's a 0 in here, you're done, right? Because when you multiply it all out, it's going to be 0. You know that. So you don't have to do the rest of them, right? So there's this advantage of being able to short circuit your operation. So the 0 value of a function, it's a property of a function. It basically tells you where to stop calculating, and you know the answer already. The 0 value becomes the answer. Like I said, it comes from multiplication, and the property is pretty simple. If you do a times 0, the answer is 0, no matter what a is. If you do 0 times a, you get a 0, no matter what a is. And so this property is the same. You just swap out the operation. So the 0 value with the operated on some other value, it's always going to be the 0 value. And it doesn't matter what position they're in. So not all functions have them. That's important to say. It's not as common as the identity. We went over the identity value in another episode, but the 0 is a lot less common. It's less common to be able to just stop like you can with multiplication. But we'll go over some that are we use them all the time in programming. So in JavaScript, there's a value called not a number. So if you happen to do some calculation, buggy code, you get a not a number out, right? It's not a number is oddly a number, like the type is a number, but it's called not a number. If you get one of those, anything you do to it, and any other mathematical operation, also yields not a number. So you can basically stop. If you have a not a number, that not a number will be your final answer. So that's a 0. The interesting thing is not a number is a 0 for every single mathematical operation in JavaScript. So that's pretty cool. It's a way to just stop working. You got some error in there that you messed up. Some languages have null as a 0 for some operations. You could imagine if you let's say you had an object and you called a method on it, and the method returned null, and you're chaining. So now you're going to call a method on that null, and then it's just going to say operation not found, which returns null, and then you're going to do an operation not found on that operation. So it's just going to be over. You're done. You're going to get a null out. And then the problem is, where did the null come from, right? Just like, where did the 0 come from when I was multiplying, or where did the not a number come from? You lose track of where that answer comes from. Sometimes you'll have an error value that becomes a stop to the whole thing. So in Haskell, you'll have nothing. Nothing is a 0. So if you have a maybe, a function that returns a maybe, or that operates on a maybe value. Once you have nothing, there's no more operations to do when you're dealing with nothing as a zero of the operation. So nothing. Once you get a nothing, you're always going to have a nothing, and you can't get a value back. Now you could make an operation that doesn't use nothing as a zero. Okay, so there's that. But if you are using nothing as a zero, once you get a nothing, you're just going to have nothing forever. So that's important to emphasize, because it is a choice that you have when you're programming. Is this going to be the end? Or am I going to use some, like, let's say, a default value if I don't know the answer to something? If I get a null, maybe I'm going to check and I'm going to kind of replace it with some other value that I know, right? Not let that null bubble out. You could look at, now this is probably kind of controversial, but you could look at something like an exception, which, if you're in a loop and you're multiplying numbers together, okay, and you hit a zero, how do you get out of that loop? You could have a check, or you could throw an exception, and that will just bubble you out of the loop, right? And so you could do something similar where you say that exception stops all calculation, right? Now you're going to have to catch the exception somewhere, but it's a similar idea that this is where we stop. If I throw an exception, I'm just not going to continue anymore. There's also this idea in a system like a message passing system where, like, let's say you have a worker thread doing work for you, and you want to tell it, okay, let's stop, it's done. Like, there's no way to communicate out of that message channel that you've got for that worker. You can't just like stop the thread, because some systems don't let you stop a thread from the outside. So you need some message that says stop, that you're done. And so this is actually has a name. It's called a poison pill. You're passing all these values down to your worker, and then at some point you say, okay, I'm going to put a poison pill in there, and that's going to kill the worker. It's going to consume it and kill it. And all it is a value. It might say like kill or die or something, quit. And the worker knows about this. The code in the worker has a condition for it, and it's just going to end. It's going to stop. And so this is the same idea. You have all these messages. These are just normal values, and then you have this zero value that's like, I'm done. I'm going to stop. It's the poison pill. This is translating this algebraic idea into a more imperative, time-based idea where you're doing message passing. Okay, so let me recap. The zero of a function basically tells you what values you can stop on, where you don't have to do any more calculation. And if you're doing dynamic programming, like, you can just stop. You can just say, I have zero. I don't need to run through the rest of the list. And that becomes the final answer. The property is very simple. 0 times a is going to give you 0, and a times 0 is going to give you 0. That means 0 is a zero of multiplication. So once you have that 0, you can stop, and not all functions have them. It's a choice that you can make. You can make a special 0 value for your operation that will have this property. If you need that, if you need something to say, hey, I've got a problem. I want the problem to bubble out to the next thing. I don't want this to be operated on anymore. That's a use for it. It's used a lot in like monads and things like that to just say, okay, we're done with this monad. We're getting out of here. We got an error. Let's just get up to the top. We're going to stop all calculation. JavaScript's not a number is a 0. Some languages use null. You could even think of like promises, like once you have canceled a promise, it's done. Like none of the then things are going to run, and that's going to be the final answer. No matter how many thens you've put on there, they're just not going to run, and so it's going to stop the calculation. And then in the message passing domain, there's the 0 called the poison pill. Okay, I think it's a cool idea to think like there is some value that when I get to, I know how to stop. And I think you could do yourselves a favor and just look at your existing operations with this eye for thinking, when could I stop? Does it make sense to have some value that is the end of the calculation? That could really clear up a lot of code, right? All right, so do me a favor, please. If you like this idea exploration of algebraic properties, this property is important to know, I think, but it's probably not as important as something like the identity or commutativity or associativity. But all the same, it's very, very good to know, and very, very simple, easy property. So if you like these things, please subscribe, because then you'll get the other ones as they come out. If you have a question, if you'd like to get into this discussion with me, if you have some disagreements, I love to get into discussions over email. I'm eric@lispcast.com. You can also find me on Twitter @ericnormand with a D. And I'm also on LinkedIn, so you can find me there. And let's connect. Just send me a message about the podcast. All right. See you later.